Chapter 24: The Database That Grows With You. Tom's cost review had found something unexpected in the database tier. Nimbus was running RDS PostgreSQL Multi-AZ db.r6g.large instance. $340 per month. That seems high, Tom said, but I'm not sure what to compare it to.
Leo pulled up the performance metrics. The database CPU was spiking to 85% during Friday dinner rush.
Read queries were queuing. The P95 query latency had doubled over 6 months. The database is the bottleneck, he said. Traffic has grown. The database hasn't scaled with it. Can we just make the instance bigger? Maya asked. Yes, Leo said. That's vertical scaling. We move from r6g.large to r6g.xlarge. More CPU, more memory. It'll cost more and buy us time. But it doesn't fix the underlying problem, Priya said. Eventually we'll hit the biggest instance and need a different approach. There are 2 approaches, Leo said. Read replicas or Aurora. What's the difference? A good question. The rest of this chapter is the answer. Think of a busy library with one librarian who both checks books in and answers patron questions. When the library gets popular, a queue forms. The fix? Hire more librarians, but only for answering questions. Check-in still goes through the original desk. That's a read replica. Extra capacity that handles reads, while all writes still go through the one authoritative source. Aurora goes a step further, redesigning the shelving system itself, so every librarian shares the same shelves and always sees the same books, with no delay. Read replicas, distributing read traffic. Most web applications read data far more often than they write it. A customer browsing the menu makes dozens of select queries. Placing an order makes a few insert, update queries. The ratio is typically 10-to-1 or higher. A read replica is an additional RDS instance that receives a copy of all writes from the primary and makes those writes available for select queries. How it works: 1. Application writes insert, update, delete, go to the primary database. 2. The primary replicates those changes asynchronously to read replicas. 3. Application reads, select, are distributed across read replicas. 4. Read replicas share the load. Each handles a fraction of the total read traffic. The result? The primary database handles only writes, and optionally some reads. Read replicas handle the read load. For a 10-to-1 read-write ratio, adding one read replica roughly halves the primary's total load. Important limitation: replication is asynchronous. There's replication lag, typically milliseconds, but can be seconds under load. A read from a replica might see data that's slightly behind the primary. For most reads, browsing the menu, viewing order history, this is acceptable. For did my order just go through? Read from the primary. The details: you can have up to 5 read replicas per primary RDS instance. Read replicas can be in the same region or a different region, cross-region replicas. Read replicas can themselves have read replicas, chaining. Read replicas are separate endpoints. Your application must direct reads to the replica endpoint. Read replicas can be promoted to standalone databases, useful for DR. For Nimbus, Leo added one read replica. He updated the application to write operations, primary endpoint. Menu browsing, order history, replica endpoint. CPU on the primary dropped from 85% to 41% at peak. Tom looked at the cost. A read replica of the same instance type costs the same as the primary, from $340 a month to $680 a month. We doubled the cost to roughly halve the load, Tom said. Yes, but the alternative was moving to a larger instance type, which would also cost more and wouldn't distribute the read load. Tom did the math. He nodded, reluctantly. What's Aurora? He asked. Amazon Aurora. Rethinking the database engine. Aurora is AWS's proprietary relational database engine, compatible with MySQL and PostgreSQL. It was designed from the ground up for cloud workloads, reimagining how a relational database's storage layer works. In a traditional RDS setup, MySQL, PostgreSQL, the storage and compute are tightly coupled. The database engine manages the data files. Replication copies the data from primary to replica. The replica must redo every write operation. Aurora separates storage from compute. It uses a distributed, fault-tolerant storage layer that replicates data automatically across 3 availability zones in 6 copies. The compute layer, the database instances, sit on top of this storage layer. What this changes: read replicas. Aurora replicas don't need to replicate data. They already share the same storage layer. This means up to 15 read replicas versus 5 for regular RDS. Replication lag is typically under 100 milliseconds versus seconds for RDS under load. Replicas can be promoted to primary in under 30 seconds versus minutes. Failover. Because replicas share storage, failover is much faster. Promotion doesn't involve data transfer, just redirecting writes. Storage. Aurora automatically scales storage in 10 gigabyte increments, up to 128 terabytes. You never provision storage in advance. Performance. Aurora claims 5x the throughput of standard MySQL and 3x standard PostgreSQL for equivalent instance types. Aurora pricing. The Tom question. How much does it cost? Tom asked. Aurora pricing is different from RDS instance pricing, similar to RDS instance pricing by type. Storage pricing. 10 cents per GB per month. You pay for what's stored, automatically scaled. I/O pricing. Aurora charges per I/O request, read-write to storage. This can be significant for write-heavy workloads. Wait, Tom said, we're paying for I/O separately? Aurora Serverless v2 and Aurora I/O Optimized change this pricing model, Leo said. Aurora I/O Optimized charges no I/O fee, but a higher storage and instance price. Better for I/O heavy workloads. Tom looked at the trade-off. For Nimbus, which was read-heavy, lots of menu queries, few writes, Aurora I/O Optimized might cost more. Standard Aurora pricing might be appropriate. This is a real cost decision senior engineers make. You need to know your workload's I/O patterns to choose correctly. Scaling without thinking about instances. Aurora Serverless v2 is a configuration that automatically scales the compute capacity based on actual database load. Instead of choosing a fixed instance size, db.r6g.large, you set a minimum and maximum capacity in Aurora capacity units, ACUs. Aurora Serverless v2 scales up in seconds when load increases, scales down to near zero during idle periods. Cost, $12 per ACU hour, plus storage and I/O. For workloads with variable traffic, Nimbus's Friday spikes versus Monday morning quiet. Serverless v2 reduces costs during off-peak periods and handles peaks without pre-provisioning. So, during the Friday spike, Leo said, Aurora automatically scales up. Sunday morning when we have almost no traffic, it scales back down to minimum. And we only pay for the capacity we're using, Tom said. Correct. Tom had the expression of someone who'd found exactly what they were looking for. Aurora Global Database, multi-region reads. Aurora Global Database extends Aurora across multiple AWS regions. One primary region handles all writes. Up to 5 secondary regions serve reads with typically less than 1 second replication lag. Secondary regions can be promoted to primary in under 1 minute for DR scenarios. For Nimbus's global expansion, Aurora Global Database would let a restaurant partner in London query their local menu from the EU Red replica, while all orders, writes, still go through the US primary. RDS versus Aurora. When to choose each factor. RDS PostgreSQL MySQL. Aurora cost, lower for small workloads. Higher base, but scales better. Compatibility. Full MySQL PostgreSQL compatible with minor differences. Max replicas, 5, 15. Replica lag can be seconds, usually less than 100 milliseconds. Storage, fixed provisioning. Auto scales to 128 terabytes. Failover time, 60 to 120 seconds, less than 30 seconds. Serverless option, limited. Aurora Serverless v2. Best for stable, predictable workloads. Variable traffic, high read volume, need for fast failover. Strengths and limitations. Aurora strengths. Significantly faster failover than standard RDS. Up to 15 read replicas with minimal lag. Auto-scaling storage. Serverless v2 for variable workloads. Global database for multi-region deployment. Aurora limitations. Higher cost for small, stable workloads. I/O pricing can be significant for write-heavy workloads. Use I/O Optimize for this. Minor MySQL PostgreSQL compatibility differences can require code changes. Serverless v2 cold starts from near zero can cause latency spikes. Summary. Read replicas distribute read traffic from the primary.
Asynchronous replication, slight lag acceptable for most reads. Aurora reimagines the storage layer. Distributed, shared across replicas, auto-scaling. Aurora offers 15 read replicas, less than 100 milliseconds replica lag, less than 30 seconds failover, up to 128 terabytes auto-scaling storage. Aurora's serverless v2, auto-scales compute capacity based on load. Good for variable traffic. Aurora Global Database, primary in one region, read replicas in up to 5 regions. Choose RDS for smaller, stable, predictable workloads. Choose Aurora when you need scale, fast failover, or variable traffic handling. Exam tips. SAACO3 domain. Design high-performing architectures. Domain 3, Task 3.3. Aurora Replica versus RDS Read Replica. Aurora Replicas share storage. Near zero lag. Less than 30 seconds failover. RDS Read Replicas replicate data. Lag possible. Aurora Serverless v2. Auto-scale database capacity. Unpredictable or spiky database traffic. Scale to 0. Aurora Serverless v2. Aurora Global Database. Multi-region database. Read from EU with low latency from US primary. RTO less than 1 minute for regional failover. Aurora Global Database. Failover timing. Aurora less than 30 seconds. RDS Multi-AZ 60 to 120 seconds. No both. Aurora I/O optimized. Higher storage and instance cost. No per I/O charge. Use when I/O costs dominate. Write heavy. Standard Aurora. Lower storage cost. Pay per I/O. Aurora backtrack. Rewind the database to a specific point in time without restoring from a backup snapshot. Available for MySQL-compatible Aurora only. Exam signal. Accidentally deleted data. Need to recover quickly without restoring a full backup. Exercises. Exercise 1. Recall. Explain the difference between Aurora and standard RDS read replicas. Why is Aurora's replication lag typically lower? Hint. The key difference is shared storage versus data replication. Think about what each replica must do when a write arrives. Exercise 2. Exam practice scenario. A social media platform's MySQL database is experiencing high read latency due to increasing traffic. The application is read-heavy, 95% reads, 5% writes. The team needs read latency to be consistent, even during traffic spikes. They need automatic failover with minimal downtime. Target RTO, 30 seconds. The data volume is growing unpredictably. Which database solution best meets these requirements? A. RDS MySQL Multi-AZ with 5 read replicas. B. Aurora MySQL with Aurora replicas and Aurora Serverless v2. C. RDS MySQL with a larger instance type, vertical scaling. D. DynamoDB with DynamoDB DAX for read caching. Hint 1. RTO less 30 seconds. Which service achieves this? Check the failover timing for each option. Hint 2. Consistent read latency during spikes. Which service's replicas have near zero lag versus potential seconds of lag? Hint 3. Unpredictably growing data volume. Which service auto-scales storage? Answer B. Explanation. Aurora MySQL with Aurora replicas provides near zero replication lag. Milliseconds, not seconds, for consistent read performance under load. Aurora Serverless v2 auto-scales compute during traffic spikes without over-provisioning. Aurora storage auto-scales as data grows. Aurora failover. Promotion of a replica completes in under 30 seconds, meeting the RTO requirement. Why not A? RDS Multi-AZ failover takes 60 to 120 seconds. Doesn't meet RTO less 30 seconds. Standard RDS read replica lag can reach seconds under load. Consistent read latency is harder to guarantee. Why not C? Vertical scaling larger instance increases capacity but doesn't distribute read load. The database remains a single point of failure for reads. Why not D? DynamoDB is NoSQL. Migrating from MySQL to DynamoDB requires re-architecting the data model and application queries, which is far beyond the scope of this performance improvement task. SAACO3 domain. Design high-performing architectures. Task 3.3, Exercise 3, Architecture Challenge optional. Nimbus is designing a global expansion. They want restaurant partners on the West Coast, in Germany, and in Australia to see their own order data quickly, without cross-region latency. All writes must go through a single US East primary to maintain consistency. Design the database architecture using Aurora. How would you structure the global database? What happens if the US East primary goes down? How would you handle the promotion process? There is no single correct answer.
The goal is to practice multi-region database design. Post-credits scene. Leo migrated to Aurora with serverless v2. The Friday spike came and went. CPU never exceeded 60%. Query latency stayed consistent. Aurora had scaled up to handle the load automatically, then scaled back down after the rush. How much did this cost compared to last Friday? Tom asked Monday morning. Leo pulled up the Billing Explorer. Friday peaked at 89 cents hour. Saturday morning was 11 cents hour. Tom said nothing. The old setup was a fixed $47 hour, regardless of load. Leo added. So we paid more during the spike than before, Tom said. Yes, but significantly less during off-peak. Net cost over the week is lower. Tom calculated, then nodded. There's a lesson here, he said. The right question isn't, is this cheaper? It's, is this cheaper for our actual usage pattern? That, said Priya from across the room, is a senior engineer's instinct. Tom looked slightly alarmed to be described that way. In the next chapter, when your network is the bottleneck, and why a private highway might be worth the toll.